in this lesson, we're going to focus on subset, proper set, superset, equal set, and equivalent set. So let's start with subset. So what exactly is subset? So let's say A denotes a set and B also denotes a set. If set A include some particular element and some or all these elements turns out to be in set B, then set A is said to be a subset of set B. What are we saying in essence is that, let's say set A denotes a set and it includes elements 1, 2, 3. And set B also denotes a set and it also includes elements 1, 2, 3. Then we can say A is a subset of B. This sign of symbols that looks like U, okay, sleeping on top the slash line, is known as a subset symbol. Okay, now we said some or all the elements in set A. Now you guys need to take note that if at all we have a case like this, set A turns out to be a set that includes elements 1, 2, 3. And set B at the same time turns out to include element 1, 2, 3, 4, 5. Then A is also a subset of B. Okay, now this particular example now brings the idea of what we call a proper set. Okay, proper set, when do we have proper set? We have proper set when a particular set is a subset of a particular set and there is at least a difference of one element between them. Okay, what are we saying in essence is that we said set A is a subset of set B, but we will observe that there is at least some element in set B that is not in set A. Okay, now if that should be the case, we can conclude and say that A is a proper set of B, which is set A is a proper set of set B. So the sign that looks like letter U that is sleeping on top its faces, okay, is known as a proper set. Okay, but when the slash line is associated with it, then it is known as a subset. So we can only have proper set when we have a difference in elements. Okay, but we can have subset at the same scenario. Okay, subset we can have it both when they are equal and when they are not. Okay, so that is subset and proper set. Now what if we want to say this in other way around? That is, we want B to be in this place and we want A to be in this place. How can we say that? Okay, in order to say this, we can say B is a superset of A. So set B is a superset of set A. So that is the basic difference between them. Okay, we make use of superset when we are trying to what? To reverse the action that we are trying to say it in other way around. We make use of proper set when there's at least some or at least one difference between their elements. We make use of subset in both cases, either when they are with the same element, that is when they are equal, or when there's some difference in their element. Okay, hopefully you guys are now be able to know the difference between the subset, proper set, and superset. Okay, so now let's go ahead and move forward to the equal set. So what exactly is equal set? Hopefully you guys have written that. Okay, now for the equal set, let's say A is a set and all the elements in set A turns out to occur in set B and vice versa. What do we mean by that? That is, all the elements in set B also turns out to occur in set A. Now, if we are to use the basic idea I've taught you guys just earlier, okay, in the preceding examples, I said when we have a subset, it means either the elements are the same or there's at least one difference between them. So we can just say this, that two sets are said to be equal when A is a subset of B and B is a subset of A. That is, all the elements in A turns out to occur in set B, and all the elements in set B turns out to occur in set A. So how do we denote this? Okay, if A and B are equal, then we said set A is equal to set B, and this can only occur, or this can only take place if and only if A is a subset of B and B is a subset of A. So now let's try to work out some examples. Okay, so let's say if T equals a set that include element 2, 4, 6, 8, and 10, and M equals a set that include element 4 and 10, and N is an set that include elements 8, 6, 4, 10, and 2. Okay, now how can we show the relationship using the subset, proper set, and superset? Now I want you guys to take note of this. In set, the order in which elements are being arranged or listed is irrelevant. Okay, just take note of that. If we have a set that includes 1, 2, 3, okay, and we have another set that includes 2, 1, 3, these two particular sets are the same, they are not different. Okay, so just take note of that. The order of arranging this element is irrelevant. Okay, now let's try to provide solution to this particular example. By the way, if you want to provide it yourself, feel free to pause the video and try to work it out. Okay, now what can we observe? Let's start with T and M, set T and set M. What is the relationship? What do we observe between them? Now it turns out that all the elements in set M occurs in set T, because we have 10 here, we have 10 here, and we have 4 here, we have 4 here. So therefore M is a proper set of T. M is a proper set of set T. Why? Because we still have some elements that are left in set T that are not in set M. Now don't forget, you can still say that M is a subset of T, but it is well advisable to just use the proper set, since we still have some little difference. Okay, well, if you use the subset, it's still the same. Okay, now let's go ahead and move to the next example. Okay, so all the elements in set N turns out to occur in set T. Okay, now let's try to figure it out. We have element 8 here. Do we have element 8? Yes, we have. Element 6 turns out to be here. Element 6 also turns out to be here. 4, 4, 2, 2, 10, 10. Now you can see that all the elements are present. So therefore, set T or set N is a subset of set T. Okay, you can write it anyhow. Set N is a subset of set T, and set T is a subset of set N. So basically, that is how to figure out if either two sets are subset of each other, or proper set of each other, or superset of each other, because set T is also a superset of set M. All right, so that's how to deal with examples or to deal with problems involving subset and superset. So let's try to work out one example involving equal set. Okay, so let's say we have A to denote a set, and it includes elements A, B, C, D. And we also have B to denote a set, and we use elements it includes element E, D, A, C. Is set A and set B equal? Now it turns out that we have one element which is known as element E. This element turns out not to be present in set A, so therefore set A is not equal to set B. Okay, before they can be equal, all the elements must be the same, and they must what? They must be present in both of them. Okay, so please take note of that. Now let's try to work out one more example involving that. So let's say we have set B or C. Let me use different. Set C to be equals element that include set that include element 1, 2, 5, and we have another one, set D, that include element 5, 1, 2. Now are these two sets equal? Now it turns out that both their elements are the same. Okay, so therefore set C is equal to set D. So hopefully you guys are now familiar with how to show the difference, or how to show if either two sets are equal or not. So now let's move to the last example, which is known as equivalent set. So what exactly is equivalent set? Okay, now before we move into that, you guys need to know what we call cardinality. Cardinality is the number of elements in a set. Let's say A denotes a set and it includes element 1, 2, 3. What is the cardinality of set A? This is denoted as n of A, and this is simply equals to the number of elements in a set. So just count the number of elements you have in set A, and that will be your cardinality. So we have 3 elements in set A, so therefore the cardinality of set A is 3. So now let's move back to what we call equivalent of set. They said when two sets has two equal or has the same cardinality, then the sets are said to be equivalent. Okay, now what are we saying in essence? That it doesn't matter if at all their elements are the same. What we need to be after is that their cardinality, that is the number of elements, are they the same or not. So please make sure you know the difference between equal set and equivalent set. Equal, the elements must be the same, okay, and the cardinality must be the same. Why for equivalent, it's not necessary that the elements are the same. We just need to make sure that the cardinality are the same. So let's try to work out an example. Okay, so let's say A is a set. So A should be a set that include element 1, 2. Let me use different example. Okay, so that it won't be as if I'm using same example or this one. So let's say it includes elements 3, 9, 2, 8. Okay, and set B include element 4, 5, 1, 3. Are these two sets, are they equivalent? Now the fact that the cardinality of set A is 4, the cardinality of set A is equal to 4, and at the same time the cardinality of set B is equal to 4 as well. So the fact that their cardinality is the same, so therefore set A and B are equivalent. Okay, so the symbols we use for equivalent is known as, is in this form. Okay, something like this. Okay, so both of them are equivalent. So basically that is how to figure out if two sets are equivalent or not. So hopefully you guys are now able to know the difference between all these types of sets. Okay, so please, if you like my video, please give me a thumbs up. If you haven't subscribed to my channel, please make sure you do that right away. So see you guys in the next video. So I have an exercise for you guys to practice. So here is the exercise. So if you want me to review your answer, feel free to comment it in the comment section below, and I will give you a feedback as early as possible. Thanks for watching once again. See you guys.